So in this video, we're going to talk about how to solve systems of linear equations by graphing. So remember that a system of linear equations consists of two or more linear equations that have the same variables. This year, we're going to be working with two variable systems. That's why each of our systems has two equations. So to solve a system of equations, what we're going to do is we're going to find an x and a y value that makes both equations true. So since we have an x and a y value as our solution, we can write the solution to the system as an ordered pair. So you can check whether an ordered pair is a solution by plugging it into both equations and making sure that it makes both equations true. So for example, if we want to verify whether 5, 1 is a solution to the system, we're going to plug 5, 1, which is an x and y value, into each of these equations. So when I plug it into the first equation, I get 5 plus 3 times 1, and I'm checking whether that equals 8. Well, 5 plus 3 times 1 is 5 plus 3, and that does in fact equal 8. Now I plug into the second equation. When I plug in, I get 2 times 5 minus 9, and I'm checking whether that does equal y, which is 1. So 2 times 5 is 10, so I have 10 minus 9 equals 1, and 1 does in fact equal 1. So that is telling me that 5, 1 is the solution because it makes both of the equations true, so it is the solution to this system of equations. So there are three ways to solve systems to find that solution. You can solve them by graphing, you can do what's called substitution, or you can use a method called linear combination. So in today's lesson, we're going to talk about how to solve systems by graphing. So to solve systems by graphing, you're going to start off rearranging each equation into y equals mx plus b form. So remember, your equation has to be in y equals mx plus b form, whether you're graphing by hand or on your calculator. Then we're going to look for the point of intersection. So to find the point of intersection, I honestly think it's a little bit better to use your calculators because sometimes when we're graphing by hand, our lines may not be perfect and we may have to approximate. So if you're using your TI calculator, you're going to have to use the calculate and then choose the intersection feature to find the intersection point. If you're using Desmos, you're just going to click on the point to see its coordinates. So for example, let's solve this system of equations, y equals 2x minus 1 and y equals x plus 4. So the nice thing here is that both of my equations are already in slope-intercept form. So I can solve them by, if I want to, graph by hand. So I have y equals 2x minus 1, which remember means that m equals 2 and then b equals negative 1. So I'm going to graph this by going to negative 1 and then going up 2 over 1 and then connecting these points to form the graph of my line. So this would be the graph of my line, approximately. Okay, and then I have y equals x plus 4. So when I graph y equals x plus 4, the number in front of x is going to be m. Remember, if there's no number there, that means there's a 1. 4 is the value of b. So if I graph this, I would say my y-intercept is 4, and then I go up 1 over 1 to find my next point. And then I'm going to connect these points to form the graph of my line. So when I graph these two lines, I notice that there's an intersection point, which I think that intersection point is about here at 5, 9. So I'm kind of estimating that 5, 9 is the solution based on what I've graphed, but we can use our calculator to tell us exactly. So to do this, we're going to go to y equals, and we're going to enter these equations into y1 and y2. So to enter these equations, I'm going to do 2x minus 1, and then hit enter, and then I'm going to enter x plus 4. Now I click graph, and you can see the graph of my system of equations, and then I click second and then this trace button, because you can say it says calculator up here. So I click calculate, and then I choose option 5, which says intersection, and then hit enter, and it says first curve, and you can see the cursor is on my first line, so I hit enter. Second curve, and then you can see it's on my second line, so I hit enter. And then now it's asking me, do I want the calculator to guess the intersection point? And I do click enter. And it does tell me the intersection is at 5, 9. Like I said, you can also do this using Desmos. So you can type each of your equations in y equals 2x minus 1, and then hit enter, and then type in y equals x plus 4. And then now you can see it's graphed both of these lines. And then when you click on the intersection point, it will tell you its coordinates. So the intersection point is at 5, 9. So this is in fact the solution to the system of equations, which you can verify like I showed you on the previous slide. You can plug in 5, 9 for x and y and make sure that it is a solution. So you would have like 9 equals 2 times 5 minus 1, which is 9 equals 10 minus 1, which does tell you that 9 equals 9, which is true. If you plug it into the second equation, you get 9 equals 5 plus 4, which once again is telling you that 9 equals 9, which is true. So 5, 9 is the solution to this system of equations. So if we try solving the system of equations, 3x plus y equals 7 and negative 2x plus 3y equals negative 12, we're going to have to do a little bit of extra work because notice that neither of these equations is in slope-intercept form. So we want both of our equations to be in y equals mx plus b form, which remember means that y is by itself on one side of the equation. So I'm going to first take 3x plus y equals 7 and rearrange it into slope-intercept form. Well, 3x is a positive 3x. So I'm going to do the opposite of that and I'm going to subtract 3x from both sides. So when I subtract 3x from both sides, I get y equals negative 3x plus 7. So now I have the equation negative 2x plus 3y equals negative 12. So I'm going to do the opposite of negative 2x and I'm going to add 2x to both sides. So when I add 2x to both sides, on the left side I have 3y, and that equals 2x minus 12. Now to get y by itself, I'm going to divide everything by 3. So when I divide everything by 3, I have y equals 2 over 3x minus 12 over 3, which is 4. So now I'm going to show you how to do this on your calculator. So I'm going to go to y equals, I'm going to clear what I have and I'm going to enter both of these equations. So negative 3x plus 7, hit enter, and then we have 2/3 x minus 4. And then when we click graph, we can see the intersection point, but we can also have our calculator figure it out for us, right? We do second and then calculate. Choose option 5, which is intersect. Hit enter. Enter, enter again, and then it tells me the intersection is at 3, negative 2. So 3, negative 2 is the solution to the system of equations. We can also do it on Desmos. I'm going to clear what I have, and I have y equals negative 3x plus 7, and then I have y equals 2/3 x minus 4. And you can see once again that the intersection point is here at 3, negative 2. So now let's try solving this system. We have x plus 3y equals 9 and 4x minus 2y equals 8. So I'm going to have to rearrange both of these equations once again into y equals mx plus b form. So I take x plus 3y equals 9. So this is a positive x, so I'm going to do the opposite and subtract x from both sides. So when I subtract x from both sides, I get 3y equals negative x plus 9. And now I need to divide every term by 3 to get y by itself. So I have y equals negative x over 3. Remember that negative x is a negative 1, right? So that's going to be negative 1/3 x. And then I have plus 9 over 3, which means 1/3 x plus 3. That's my first equation. So now the second equation, 4x minus 2y equals 8. This is a positive 4x, so I'm going to subtract 4x from both sides. And then that gives me negative 2y equals negative 4x plus 8. So to get y by itself, I'm going to divide everything by negative 2. So when I do that, I get y equals negative 4 divided by negative 2, which is positive 2x. And then I have positive 8 over negative 2. Remember, a positive over a negative is going to be negative, so I have minus 4. So if I graph both of these in my calculator, I'm going to go to y equals and then clear what I have. So I have y equals negative 1/3, negative 1/3 x plus 3. And then in the second row, I have 2x minus 4. And I'm going to click graph. And then I can kind of see my intersection point. And I click second, calculate, choose option 5, hit enter, 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 and then enter again. And then it gives me the intersection at 3, 2. So 3, 2 is the solution to this system of equations. So now let's try solving this system of equations. We have 2x minus 5y equals negative 25 and negative 4x plus 5y equals 35. So once again, I'm going to rearrange both of these equations into y equals mx plus b form. So I have 2x minus 5y equals negative 25. I'm going to start off by subtracting 2x from both sides. So when I do that, here these 2x's cancel, so I have negative 5y equals negative 2x minus 25. Now I'm going to divide everything by negative 5 to get y by itself. So when I do that, on the left side, I'm left with just y. I have a negative 2 over negative 5. Remember, when I have a negative over a negative, it becomes positive, so I have 2 over 5x. And then I have a minus and a negative, right? So once again, I have two negatives, so that's going to become plus 25 over 5, which is 5. Now for my second equation, I have negative 4x plus 5y equals 35. So once again, to get y by itself, I'm going to add 4x to both sides. So when I do that, on the left side, I have 5y, and that equals 4x plus 35. Now to get y by itself, I'm going to divide everything by 5. So when I do that, on the left side, I have y equals 4 over 5, so that's 4 over 5x plus 35 over 5, which is 7. So just to change things up, I'm going to do this one in Desmos. So I'm going to enter both of my equations in Desmos. So I have y equals 2 over 5x plus 5. And then I have y equals 4 over 5x plus 7. And you can kind of see the intersection point already on the graph. And when you click on it, it will tell you that the solution to this system is at negative 5, 3. So that is the solution to this system of equations. So remember, to solve by graphing, you're going to need to first make sure that each of your equations is in y equals mx plus b form. If necessary, you may have to rearrange the equations. Then you're going to graph the lines using the slope and the y-intercept. You may use your calculator or Desmos to graph if you prefer. Then you're going to look for the intersection point, which is where the two lines cross. Remember that this point is the solution to the system of equations.